Hello, everybody. I want to tell you a little bit about the work that we've been doing down here at the South Pole. So we've been drilling down into the ice almost 2,000 meters, 2 kilometers, very, very far. And the reason we need to dig down so far is because the oldest ice going back in time is that deep down. And we want to know what the carbon dioxide levels were like hundreds and hundreds of years ago. So in order to do that, we need to be looking at the oldest ice. So we drill down into the earth and we pull out the ice cores. We get these ice cores that look a little bit like this. They're about 50 centimeters long and about 14 centimeters wide. And we put them through a machine which analyzes the gas bubbles inside of them. And it tells us a lot. It tells us about the carbon dioxide concentration in that time. So we're talking about hundreds of years ago, thousands of years ago, and it gives us a very, very accurate picture of what the climate was like with regards to CO2 and other gases around that time. And of course, this is really useful because we can compare this to the air balloon data that we get from places like Mauna Loa and our air balloon data that we get from here down in the South Pole and up in the North Pole and in Canada and all over the world. And we can get a very clear picture of what is happening to CO2 levels. Now something is very, very startling indeed, and we're just starting to see this pattern emerge, where you can see here back in the 1980s, back when they started measuring global temperatures, you can see here that we've got the CO2 ice cores, and we've got the CO2 from Mauna Loa, the historical data, and we can see that there is this clear matching of what is happening with the CO2 data, this brown line and yellow line, and what is happening with the global temperatures. You can see there is lots of fluctuation in the global temperatures. We can't figure out what that is, but maybe you can look at that later. But you can see the trend is the same. It is going up at a startling rate, and it is getting more and more pronounced in the last century. Now, of course, a scientist is only as good as his data. We cannot make judgment just based on one or two locations. We have to make sure our data is reliable. We have to make sure that the same thing that is happening in Mauna Loa and in the South Pole is happening everywhere. So in the next activity, you are going to look at data from across the earth, and you are going to compare it, and you're going to analyze it, and you're going to come back with some very, very rich findings and attempt to try and explain them. So thank you for listening.